CNCF April meetup. So topic for today is that, yes, we're gonna have a, let's say, topic is Kubecon Reloaded, some matrix terminology, had to figure out some joke in here, of course. A little bit late, sorry for that. You may notice that we have the sudden crash in our beverage system over there. We need to fix that one. So there's some snacks, there's gonna be some pizzas, so enjoy the evening. So nice to see so many of you. My name is Erno Kurki. I work for Google Cloud here in the Helsinki office. I've been meetup and conference active for some years now, and then there's a couple of people, us here, who are hosting and organizing the CNCF meetup. So I think many people know Lucas, the stable pillar of this ecosystem. Kervinen, Maryam somewhere over the back, over there, and then Janne, who also just joined our group from Elisa, and he's gonna also give a talk today. So we have a little bit of recap from the Kubecon Paris, which was, I think pretty much about a month back, about the topics, revisit some of the topics, and Maryam is going to talk about a little bit of her experience with the conference. Then we have Antti Kervinen from Intel talking about CPU Affinity for enhanced performance across your workload portfolio. Very much related also to the AI ecosystem, AI serving on top of Kubernetes. Then CRD usage with IDP by Janne. And we are part of Cloud Native Nordics, so it's not just Helsinki, there are also other Nordic nations. Iceland, there's one chapter in Reykjavik, then there's Bergen, Oslo, Stockholm, and of course we try to do a lot of collaboration across the Nordics communities to get the speakers over. And there's even plans that we could have a Kubernetes community days, maybe early 2025. So let's see how we can pull that off. And definitely if there's people interested in that, so please come and vetäkää vihasta. Yeah, talk to us. Yes, contact us. Welcome new members. I just checked, so it's exactly 1,800 members in the CNCF Helsinki club, and we are part of the CNCF Linux Foundation, and we follow the code of conduct. In short, be nice and respectful for each other and include everyone. Join the community. So there's check working, yeah.
It's running out of battery.
Probably. Maybe I just raise my voice. We have the Cloud Native.
It's breaking.
It's breaking. Okay. Can you hear me if I just raise my voice? Yeah, because I hate mics. So, but we have some more mics here. Whose mic?
Yeah. You're biased towards Mike.
We're biased towards Mike. So there's the Cloud Native Nordics Slack, where there's a lot of communication going on. Then of course you can follow us on X, and then you can find all the recordings from these events from the YouTube channel, not just Finland, but also across other Nordics. So there's lots of interesting content to dive into if you don't have anything else to do in the evenings. We're always looking for new speakers. So how these meetups work is that there's also always a host that provides the premises. There's always a sponsor, and quite often the sponsor and host are the same, that the sponsor provides the drinks and beers, but then there's like speakers. And because we're in Finland, it's sometimes difficult to find people who are willing to stand up and give a talk on their favorite topic, but don't be shy. I think it's a very, nice community. No one is discriminating you on what you ramble in here. So just again, like talk to us, the organizers here, and there's also the QR code, which is the kind of one of the most popular forms of phishing attacks nowadays. So you can scan that and also submit your idea on talks. So trust the QR.
And also for sponsors, we're thinking about, so the next one's in May, and
that's right.
Maybe a special one in June, and we're looking for places to be sort of like
Yep.
sponsor for those things. So,
yeah, we always try to plan a little bit ahead to have a queue of meetups and a couple of talks. So, it might be next meetup, or it can be a couple of months from now on. It can be in the autumn. So if you know that you are working on something interesting or that you would like to showcase, and especially all those, battle stories, they are the most important and interesting ones that we want to, and the community wants to hear about. So, Cloud Native Computing Foundation. What is CNCF? It's founded in 2015. It hosts these projects that form up the ecosystem. So, of course, a lot of the interest is around Kubernetes, but there's also so many other projects that the CNCF is composed out of. And it's really about an open source project. Gerke here is, really our open source specialist. So I think he's happy because, even for me, I feel it's difficult to kind of find out that, what is actually open source and what are the different types of licenses. He's our man if you want to know about how to define these things.
You can talk to me, or if you are very interested in the topic, there is a Helsinki to-do meetup when we are talking about these things for hours.
Yes. Yes.
About licenses for hours?
Licenses, open source compliance policies, CRA nowadays, that's very trendy.
Yeah.
Sounds scary.
Yes, sometimes. And lawyers are also involved.
Yeah. But established in 2015, I can talk a little bit about sponsors and companies a little bit more, but the idea behind CNCF is that, of course, we're talking about Cloud Native Computing Foundation, but it's not just cloud computing. So it's really about the principles are faster code reuse. What's happened?
Oh, I think you're out as a slideshow and in a browser.
Yeah, probably.
It crashes something.
It crashed.
Yeah.
the display driver.
Crash number 2. I cannot get out of this image, apparently.
Do you want another laptop?
Yeah, maybe.
This is interesting.
That's a first.
That's the first one.
Nobody's doing this, we can sort some.
And we'll be right back.
Eat and drink.
You didn't change anything from morning? I had it open from morning.
Okay, that's great. I just have it here. So.
it's coming. It is taking some time for that.
Yep, got it ready. And we're back.
Nice.
So let's trust the Apple hardware. Is this Apple? Yeah, it is.
Objection.
Object. Faster code reuse, improved machine efficiency, more reduced costs, yes, of course, and increase the overall agility and maintainability of applications. This is what we are striving for. CNCF project maturities. So there are a lot of these early stage sandbox projects, and when they get farther, they move into incubating one. But there's always, of course, the chasm that you need to cross, that the most prominent projects get into the graduation phase. The graduated projects here include, of course, Kubernetes itself, but then many of the other projects in the CNCF ecosystem. A lot of people talk about ArgoCon CD, TRKV, Kida, Flux, Fluentd for the monitoring part, Istio for the service mesh, and so on. Incubating ones, the projects that are moving on, and a lot of those which have created a lot of traction lately. Of course, there's been a lot of, for example, Backstage. Knative has been for quite long there. So Knative is the Kubernetes native serverless components, and so on. And some of the kind of later ones, especially related to today's agenda, is Volcano. Sandbox projects, even more of them. So this, if you look at the CNCF canvas at the moment, how many projects there are, so it's spreading quite fast. So it may take a lot of time to look into like what is it that I want to work with, but of course because that's the thing that I especially enjoy about the open source ecosystem is that you get a lot of the industry traction and industry information and insight in what you should use. CNCF ecosystem support. So the mission is to make the cloud native computing ubiquitous. How it's built out of is that for the, let's say, the kind of different organizations, there's the governing board, and which part is also the marketing community. So it's these vendors that you saw earlier, so bigger technology companies that supply, of course, a lot of the funding. Those companies who are part of it fund the organization and its functions. Then the technical oversight community, so there's 11 top technical architects that take care about what is going on in the CNCF ecosystem, admit all those new projects, and also act as a resource to the projects. And then end user community, which is basically all the users in here, and everyone is of course very welcome to join one of the SIGs, so special interest groups that works on some of the technologies, and user groups like this Helsinki community that we have here. And also, yes, one of the key things is that to communicate back of the requirements and good and bad experiences working with these technologies. CNCF user Tech Radar. Tech Radar is again a guide that again helps you with most of the technologies, because of the plethora of the available projects, the radar helps you choosing the right technologies and tools. Trail map, you can find it here in the links. I think this will be shared with you. So it's again like a guide that helps you find out what projects can be used for which kind of purposes. Cloud native philosophy. Lucas, can you say about the philosophy? Do you want to talk about this or speed up?
No, I can do.
Yep.
Was just posting to
Yeah.
to all those Slack channels about the live stream of this meetup. So I will actually talk a little bit more about this in the lightning talk from the poster, but just as a kind of starter. The idea is that we have a little bit of a different mindset with cloud native kind of set of patterns and practices than was common before, where we want to build and run scalable applications in all kinds of different environments. And well, both the scalability part and the kind of environment agnosticity is putting some kind of makes you choose some design decisions over others. So that means we can run our software anywhere, even on like Raspberry Pis and stuff. And containers and service meshes and all of these things are examples of this, microservices, but they are not like cloud native is not a single technology or anything. It's a way of thinking about this approach. Some consequences of this approach is as well that we get more resilient software, manageable and observability, because we're trying to get that into the software, kind of into the design before writing a single line of code to begin with. So automation is definitely on the kind of forefront, but then with that, we want to get into a place where we can deliver changes in a kind of frequent and safe way still. So it's all about the paradigm, the way of doing things instead of exactly, for example, what it is. So cloud native is not the same as containers. You can still do all kinds of other interesting stuff. There was quite a lot of talk about WASM, WebAssembly at Kubecon. People are still running big virtual machine clusters with Kubernetes using this kind of mindset, and all kinds of other things as well. It's also not the same as the economic model of buy versus rent. That is the cloud. Like if you should buy your stuff or if you should rent it, that's not the same as a way of thinking about stuff when you're developing your application, which is cloud native. So it's all about kind of defining interfaces between different components and making those kind of components themselves self-heal, for example, and have well-defined behaviors between each other. So lots of CNCF projects actually are only a specification, and hosting a way for other projects to become interoperable by saying that this is, for example, the way to do container networking, or this is the way to do storage to attach to dynamic environments and stuff. So this is the way that we get this kind of environment agnosticity as well. And Kubernetes in itself is, as a consequence, kind of a platform for platforms. So the idea is that instead of kind of building it all yourself, like here, you have to pick a set of environments that you want to do. You have to build every single thing with regards to kind of scheduling distributed applications. But if we have something, if we kind of split the landscape and say that, well, some of the common stuff we code into the Kubernetes project, and then there are extensions in this way of like where you run them, and then you can build your own kind of preferred opinionated, kind of add your opinions on top with a much smaller shell. And actually, I'm really glad that we have Janne talking about custom resource definitions, because what is this? Well, that's exactly custom resource definition that we're going to look at. So like, you want to give something that is a high-level kind of opinionated approach to your developers internally. Kubernetes is not. It's not even meant to maybe be used directly for kind of low-level stuff. So that's a kind of bridge that you can build in between, and that's the whole point of the project, that it works for that. So yes, and then Maryam.
Let's see if this works.
It works. Yeah.
All right, a few words about certificates and trainings. CNCF has lots of trainings and certificates available that you can go and see for yourself. So the CKA is the first one, the Certified Kubernetes Administrator. There is Application Developer Certificate, Security Specialist, Security Associate, and Cloud Native Associate. And in this Kubecon, CNCF announced that if you have all of these 5 exams passed and have these 5 certificates, you can be recognized as Kervinen. So that's a new thing as well. There are also many training courses, free or not free, which you can probably find useful. There are courses relevant to Kubernetes or other CNCF projects such as Cilium, Argo, many different trainings. They also have other certificates recently about like Argo, GitOps, many other things, not specifically about Kubernetes itself. And also a few words about community. We have these programs, these meetups. You can get in touch with ambassadors. Mentorship programs are available if you would like to participate. You can be either a mentee or mentor in these programs. There are Cloud Native Community Days, KCDs, which Erno mentioned that we are hoping to organize one in Finland. There hasn't been any in the past, but there are lots of those happening already in other countries. So you can also attend those conferences. Those are the smaller scope conferences such as Kubecon, but Kubecon is the largest one. So this year, 2,000 people, I guess. 12,000, yeah. And the next Kubecon is happening in November, Salt Lake City, Utah, if you are gonna travel to this. But there are also these kind of cases happening around Europe as well, if you are interested. So KCD Barcelona, Zurich, Italy, Munich, and etc. You can just figure out all these in the CNCF community website.
Yeah,
and
all of the KCDs are run by volunteers, so like no payment for the organizers or anything, all for non-profit. But the Kubecons are very big.
Yeah, exactly. So yeah, these are all the ways that you can reach out to us, and we have our GitHub, our Slack channel, the meetup group that you perhaps know since you are here. We just launched our community chapter in community.cncf.io. You can also check it out, join there, and you will receive emails when there is a new meetup. And yeah, that's it. But we will have the recap now. Is it now, or we have a break?
No, we can have a small break in between.
Yeah.
Yes. Okay. Yeah. So 5-minute break. You can go and get some refill and yeah. more food and snacks.
No, I'm not. Can you have a dance?
Yeah, I can switch it.
an article about my experience, and I would just repeat it here shortly, and I will give more time to others. So these are my impressions from attending the Kubecon. First thing maybe I want to mention about Cloud Native Rejects. It's a smaller scope conference which happens a few days before Kubecon. And in case you were to send a talk submission and it was rejected, you have the chance to also submit to this conference. It's a smaller scoped conference with, I guess, around 200, 300 people, but it's a very nice environment. All people that have interesting talks and are coming to attend Kubecon. So many people don't know about this conference, but it's a very nice opportunity as well to submit some talks. Then a few words about Contributor Summit. It's happening as a side event at the same time as Kubecon. It's in the first day usually, and people who are part of Kubernetes orgs or are sponsored attendees, they can attend this event. So if you are anyhow contributing to the project, you should definitely attend to this event. It's a very nice place to meet all people who are contributing. So it was a great place for me personally to meet many people that I've met virtually online, but that was a chance to meet them in person.
Or if you just want to start contributing, that can also be a good place.
Yeah, definitely.
So it's like a training platform?
Kind of, yeah. It can work as that.
Yeah, and this event totally happens based on volunteering work. So I had the chance to get volunteer this year. You should definitely try it. It's not a big job. I was just passing by microphone to audience, and there weren't much attendees. It wasn't busy sessions, so it was a very easy task. But this event totally happens based on volunteering works. So it's very nice if you have the opportunity to help and volunteer. Then the co-located events happen in the first day of Kubecon, which I will call it day 0. It's not part of the Kubecon. Kubecon starts the day after it. On this day, many side events are happening all at the same time. For example, ArgoCon, Platform Engineering Day, CiliumCon, I don't know all the names, many other events. And since I was joining the Contributor Summit, I didn't have the chance to.
Question.
Sure.
These side events, are they in the same venue or somewhere nearby?
No, it's exactly in the same venue, just different rooms. So
And you have to pay this still for the whole con in order to attend to those?
the price is different if you want to attend only Kubecon or also the co-located events. So it's a bit more the price.
And you cannot attend only the co-located events.
Yeah.
Okay.
But if you buy the ticket early, it's essentially the same price as well. So, yeah. Get the ticket early and then we won't be able to.
Yeah. About keynotes, so it seems like, to me, it was like this year there were themes for the days. So day 1 was all about AI. So everywhere you were going, you were hearing AI, 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 nothing else. And maybe it wasn't a surprise since we have all been hearing about AI in the past year. But yeah, that was it also in the Kubecon day 1 keynotes, and most of the talks were about AI. The second day theme was mostly about sustainability, but there were also other talks. I wasn't unfortunately able to attend day 3, but I heard that theme, I mean, I didn't have, I checked CNCF blog post, They published a nice blog post this year writing about details of what was happening in these 3 days. And they mentioned that theme of day 3 was about future of Kubecon and what happened in the past decade since Kubernetes 10's birthday is quite close.
Yeah, they also had a nice on community and inclusivity panel and stuff.
Yeah, yeah. How much time I have? I can pass by this. Solution showcase, I was really interested in that section because there are project booths and also companies presented there, and you can just pass by people, ask people questions, talk with people, find friends. So that was a great place for me to be in the whole Kubecon. I attended one diversity inclusion lunch, which happens every year on day 2, and it's a small group where we were sitting together and discussing about inclusion and diversity topics. For example, why women are underrepresented in the tech and in these topics, and so on. And I also linked here a few other blog posts that people published about their own experiences, so if you are interested, you can go and check those out. Thank you. And next we have, I can't remember who we have.
I think we have
Order is arbitrary.
Lucas next.
Lucas.
Or Juho.
Okay. You can keep the, I'll use this in laptop. Yeah. Thank you, Maryam.
Thank you.
Oh. Can I get internet?
It's
If you join the,
I don't have the password.
it's the, you join the Maria, no Telia, something,
Yes.
something
I
Wi-Fi,
know what is Telia.
and it's Maria 0101 is there. Telia.
Yes.
It's Maria 0101.
How many were at Kubecon this time? Okay, nice. We had a 5th slot as well. Just
No.
if someone wants to impromptu talk about their experiences.
Sure, that's Maria 0101.
Now it says connected. Yeah, it's fine.
Yes. Let's put it back. Okay, let's. Did you put this off as well? Yes. Okay, let's continue. And I don't expect you to see this all, but maybe if you're in the front row, you're good. That's why I will talk about it, right? There was this new concept at Kubecon for this year called poster sessions. This was the idea and kind of mainly worked a lot by Nikita, one of the co-chairs. It was a nice way to kind of start bridging if we call it the gap between research, so academia and industry. The cloud native community has done a lot of stuff in a way of just let's try it and see how it works, and if it works, and then if it doesn't, then let's change, and in a very kind of agile way in that sense. but as things are maturing, there's lots of deep research still to be done in this area and kind of formally verifying things and stuff. So these poster sections were then a way to kind of, you had your poster, we made my co-speaker Maryam, we made this one, and then there were maybe 10 other people kind of showing their posters at the Kubecon in the solution showcase that Maryam mentioned. There were also other project booths where you could talk to the maintainers and stuff. And specifically, the one other that I really found interesting and that I actually was thinking at some point that I would research myself, and now it turns out that someone already has done, and they presented their poster there, which was figuring out how to find bugs in controllers in Kubernetes, kind of the business logic of Kubernetes, and through static analysis. That was really, really interesting and nice talk. I still need to read the paper later. Anyways, on our topic was about avoiding the heat death of the Kubernetes and CNCF landscape. We started off from the perspective that there's a lot of projects. Erno mentioned now in total CNCF has 180 projects around. Most of them are in the kind of most experimental, the sandbox tier, but even in the graduated tier we have a lot of these projects, and it's all kind of organic growth, right? So people come up with ideas. They want to find a vendor neutral place to kind of collaborate with other people on these ideas. So how open source otherwise works is that if you make something, a project, and even though you make it open source, you still have because you are the owner of that code, if someone else contributes to this code, you still have the copyright, and you can technically change the license later if something that's been a hot topic the recent years. You can change the license if you own that code, right? But the idea with CNCF is that if you, for example, then donate it to another entity, such as CNCF, then that will be actually the common good, right? So that is a little bit of background on the kind of CNCF, but this has led to an explosion in the amount of CNCF projects that there is, and the kind of amount of great ideas that kind of flow into the ecosystem. But of course it comes at a cognitive cost of looking at the landscape and you're like 180 things, should I be knowing about all of these? I personally, I lost track after the 7th. I kept up to 7, 10, something like that, of all of the CNCF projects. Now I just know a handful, maybe 20 of them in total. So it's really, really, it's both a good thing and a bad thing, right? And we were thinking first in the kind of about what is cloud native and how did we, with the philosophy that I was talking about really the other minute, how do we get here? And then how can we apply, if we see some of the patterns, how can we apply those on the ecosystem itself? So one of the kind of where we start off is that entropy, the second law of thermodynamics, says that kind of entropy or chaosness of a system cannot, left to spontaneous evolution, can only increase, or more technically can never decrease spontaneously. So everything in the universe becomes a little bit more chaotic all the time, right? And this heat death is that there's a physics theory of that eventually, because everything gets more chaotic, eventually the universe will only be a uniform mass of even temperature, same matter, because it eventually, all the energy just degrades. And we were thinking about this a little bit, like, okay, so I know that every code change that I do, say in Kubernetes or in some other project, leaves, or almost anything, leaves the project at a little bit more chaotic state than when we started, right? And I mean, this goes for, like, if we look at something like command line flags. things start off easy. Then you need more and more and more flexibility. You need more environments. You need more customizability. You have more users, and so on and so forth. And this is kind of, we just have to accept to some degree that this is the way, the way it is. It goes for everything else as well. But what I found interesting is that so when something has very low entropy or very low chaosness, it's order, right? But then at the very end of the scale, so this one, you can't see it here, but kind of we start with order, and then we get something that is kind of complex in the middle, but then when we get into the heat depth, we actually think about the uniform mass of the whole universe where everything is just the same temperature and the same particle. That is not complex. Or if you think about the string, which is all just A's, no other kind of bubbles. It's not complex. You can describe that with only one word or one character. But something in between here, so when it's not a lot of order nor fully uniform stuff, then something here is actually what we can call complexity. And this is not our work. Some Aronson wrote in 2011 a blog post about this, kind of complexodynamics, thinking about what the consequences are, what is complexity, and all of these kind of things. And it's quite interesting food for thought, like where are we in the ecosystem? We started off with something that was orderly. We grow and grow the entropy with everything we do, more environments, more command line flags, more features. Will we end up at the state where where everything is just arbitrary blob, or are we able to ever go back on this decreasing stuff into more orderly stuff? Are we able to say unify some of the projects in the landscape? For one example is that was good actually is open telemetry and open census. Open tracing and open census, where two projects of these kind of specifications around telemetry, they merged into open telemetry and actually managed to decrease the complexity. So there was but it took 4 years or something like that. So it's a lot of work. Then, so we were thinking about that. We were thinking about how do people or actors communicate, and then that's some Shannon theory from 48. And then around Kubernetes essentially works in the sense of promises. And Mark Burgess has written a lot about promise theory, kind of in general, like how do people promise stuff to each other? How does machines promise something to humans or vice versa? How do actors communicate with each other? And Kubernetes essentially gives you a promise that, okay, you tell me what the end state of your application definitions on your server should be, and I promise to do my best at least to fulfill that statement, right? Or that end state. This means that we all the complexity that we before had in shell scripts or random that the humans themselves went and clicked all kinds of buttons, that complexity we now encapsulate in one place, right? And of course that thing has way more complexity, but then the idea is that we can outsource from the outside into this one piece, which was why I was so excited to see that this other person on the poster pavilion had been thinking about how to solve subtle bugs in these controllers, right? But Kubernetes itself kind of consists of lots of along the lines of 30 different controllers, which all kind of promise stuff to each other, and they have all kinds of. When you make a deployment, it actually makes a replica set, which makes a pod, and the pod is scheduled, and then the pod goes to the node agent, and the node agent tells the container run them. All of that kind of this long chain. And that's the kind of components themselves within Kubernetes promising stuff to each other through well-defined APIs. But as a user, you mostly just see that I give this high-level thing and stuff works. Or at least I hope it does. So we were thinking from the CNCF ecosystem point of view, or this with Kubernetes, they kind of, the promise is they cancel out so that you see one uniform API boundary to it, right? But if we think about the CNCF ecosystem as a whole, the promises of the projects themselves between each other don't really cancel out. You need to know the intrinsics and specifics of each project to make them, like, does project A work with project B? And how about if I add project C, stuff just breaks, right? You don't know what is the kind of logical grouping of these projects. And there is no, so to say, lamp stack of the CNCF ecosystem yet. So we were thinking about that, like how do we make it? And this is just an open call to the community and kind of think about these things and stuff. And one of the really interesting things that that Mark Burgess mentioned in his book, which is a reference to this, but also has been known for a very long time, that the Dunbar was studying animals and humans as well, and their cognitive capacities of forming groups or kind of herds. So like, how many people can you know? How big can villages get where you still know all the villagers, right? And that is around 150, right? Or he concluded that it should be around 150 people you can actually know in your life. After that, they are very, very distant acquaintances, right? And the same goes for the tools. So like, my cognitive ability seems to be around 20 CNCF projects, right? It's not 180, and it keeps growing. Like, you see this curve. Funnily enough, here it starts off kind of small. Then actually this breaking point where it goes from here to here is actually COVID. So I don't know if people if people got productive and started coding when there was nothing else to do. It seems to be. So yeah, that's some interesting stuff to think about. But yeah, just thinking about these things, like, where do we get where do we get the promises of different projects to cancel out? Where do we, how do we make it easier for users to understand the technology, to kind of have logical groups and stuff, or logical dimensions of, like, what, if you compare two projects to each other, what dimensions should we even be comparing them against, right? Stuff like that. So if you want to talk about more about this, then we'll do so in the breaks. But that's it for me. Thank you. Next up is Juho. Let's see.
Was it here?
Yeah, I guess.
Nice.
Security first.
Yes, exactly. Hello. Greetings from ArgoCon. My name is Juho and I'm a senior platform engineer. I work at Metacore Games. Who here has used Argo? Argo CD, Argo rollouts? Yeah, oh, many of you. Okay, good. This talk will be just some of my experiences from ArgoCon, but also I will go through the Argo project, so the ones of you who actually have no idea what I'm talking about might know something more after this one. And I also have a little demo about me just deploying stuff yesterday with Argo, so let's see. So, what is Argo? Argo is this cute little fella with the space helmet right there, but Argo project is a collection of 4 different projects, Argo CD being the first one. It is the GitOps tool. I'll go a little further deeper on Argo CD in the next slide, but let's go through the other ones as well. So Argo Rollouts is a progressive delivery tool. You can do canary deployment, blueprint deployments, promotions between these 2 environments. It's quite a cool tool. I'll also fall into that. Argo Workflows is, again, a batch processing tool. very useful for machine learning and batch processing, data processing in Kubernetes declarative way. So instead of defining a long Python script or whatever, you can actually do it in a Kubernetes native way, defining a resource in YAML file and just having your stuff happen. Then there's Argo Events. Argo Events is a workflow automation framework, so you can, for example, define a webhook that triggers stuff. So you can, for example, a webhook that declares a Kubernetes object that Argo Events will then orchestrate. So these, of course, having the Argo prefix work very well together, and all in the heart of this is the Argo CD. Now, ArgoCon is one of the co-located events happening on day 0, as Maryam already said. It is a full day of mayhem of all things above. I think it was from 8 a.m. till 7 p.m. full of like non-stop. I was sitting through the whole thing, very tiring but also inspiring and nice event. No, like if you ever go to Kubecon and you go to these co-located events, ignore the platform con ever. Just come to ArgoCon. GitOps is the best stuff. Next up is, I think, is my little demo. Oh, well, actually, no, never mind. It's the Argo CD. So, Argo CD, the first Argo project. It's a continuous delivery tool. A bit different on how we do traditional CI/CD stuff. So instead of doing the push method, so you define your CI/CD pipeline and you commit your stuff and merge it into your main, and then you push your stuff. What Argo does is actually stands between your Git repo and your Kubernetes cluster, and it syncs between those. So whenever you deploy your merge your pull request, Argo will actually sync your state of your Git repo into your Kubernetes cluster, and it works on the reactive way. So if you have changes in your Kubernetes cluster, for example, some nifty developer goes and deletes a namespace, Argo will actually detect this and redeploy it. Same thing goes for any other things. If it's not in Git, it will not be in Kubernetes, and Argo will handle that. So your Git repo is your source of truth. Argo itself is a declarative version control application lifecycle management tool. Very fancy word of defining it. And of course, all the cool kids like us at Metacore Games, we use it. So I encourage every one of you to also look into Argo CD. Instead of having to define a YAML file of like hundreds of lines in your CI/CD pipeline, how about you just define a application set of Argo? It's a 20-line YAML file, and it does everything for you. Sounds great, huh? All right. I have a little demo pre-recorded, so let's hope it goes well. All right. So let's see. Ooh. Oh. Okay, here we go. So, what you see, I'll stop it a little and explain what's happening here. So, this is the Argo CD UI. What you see here is actually the production Argo CD environment of Metacore Games. What we do here is we have our sandbox environment, which we're targeting today. So, in here, you can see the application health, the sync status. You can see that it's synced to the last commit hash, which is in here. And you can see it's my revert commit when I messed up my screen recording the last time and had to revert, so here you go. Also, all the resources that Argo deploys are listed here, so you can see what actually is within your application deployment. So for external secrets, it deploys a lot of services and whatnot here, so you can have this pane of glass view for Argo. So here I'll be scrolling a little bit, and then I hopefully move on to my pull request. Yes. Now, what I'm doing here is I'm upgrading external secrets home child version. And, no, this. Oh, wait. Okay, we're back at this. So what I'm doing is I'm upgrading the Helm child version, and hopefully this will load. Yes.
Maybe put the resolution down.
Right. Okay, let's go to 1020 maybe. Oh God. Well.
Now it got buffered.
Okay, here we go. Okay, I will not stop it. So let's just. Here I upgrade the version. You see, I'm bumping it a few minor versions, and my colleague here has actually approved my merge request. I'm pressing squash the merge. It's going boom, here it goes. Now it's merged into the sandbox branch. So this Argo application here is looking at the sandbox branch, and we can now refresh the. I have auto-sync on, but it's a little slow, so I'm pressing the refresh button, and now we can see it's actually auto-sync. So what Argo does is it always looks into your Git repo state, and it will sync it then to the Kubernetes cluster. We can now see the little boxes here refreshing too, and the application health progressing. So this is essentially what Argo CD does. And soon we will see the app health going to healthy, and there we go. What Kubernetes does here in the background is it of course rotates the pods. New version of the Helm chart probably also rotates the containers. So there we go. And now you can see the last thing is my actual commit here, and we have a new commit chart there as well. So here you go. That's Argo CD. Okay. Over. All right. Some highlights from the ArgoCon. So 3 talks, all about different Argo products. So let's start with from the left. Space Age of GitOps. Price of Humble Pull Request by Zach Aller and Mike Crenshaw from Intuit. This is actually a really good talk for anyone who's getting into Argo CD and GitOps. It's essentially describing the current state of GitOps and its maybe pain points, and having a sort of philosophical view on what the future could look like. So, few good examples. Examples what they showed here. So points. For example, this one. Expand your Helm templates automatically in PR. So what you saw there, I did not do it, but I actually just created a pull request in that repo, so it will do it now. So I'm inspired by this talk. So when you do those little changes in your Helm templates, for example, change the version or then go ahead and change some tag or whatever, it can actually cascade into a lot of different changes. So when you open a new pull request and you have your colleague review it, it can be that there are a lot of changes that are just not visible, and for the pull request reviewer, they would have to go and write the customize build and pipe it through kubectl diff and whatnot to see the actual changes. So you can just make everyone's life easier and add that into your automation CI pipeline and just paste that into your pull request comments. Another good point is to trust in the process, trust in autosync. I know a lot of us like to turn off autosync from production, but hey, if you test it in dev, it's probably going to work in prod. So just let's trust in the process. The last point for this talk is to treat Git as the interface for your deployments. And then idea for this is that your developers are very comfortable using Git. Instead of writing hundreds of lines of YAML code into your GitHub action, how about just using Git? So this will encourage your developers to also use Argo CD and GitOps. Right. So the second talk here is from Carlos Santana and Raj Saha from AWS. This is about Argo workflows, and I already briefly mentioned that Argo workflows is a great tool for batch processing, machine learning, and stuff like that. But what it also can do, it can orchestrate these cluster operations. So in this talk, Carlos and Raj were mentioning that some Kubernetes operations. All right. So some Kubernetes operations can be automated via Argo workflow. So this talk, especially for EKS users, is interesting. What happens here is they are describing a migration from Amazon Managed Node Groups to Carpenter. So for EKS context, Managed Node Group is the traditional way of declaring nodes. It's very reliable, but painfully slow to scale up and down. So what Carpenter does is essentially the same. It's AWS created a tool. It's donated to CNCF, I guess last year. And what it attempts to do is to keep this reliability, but also increase the speed of provisioning these nodes. So in this talk, there's a great demo about migrating the workloads from the Managed Node Group into Carpenter using Argo workflows. So give it a look. Essentially what happens is you extract the metadata, enable Carpenter, inject that metadata to the Carpenter and your applications, and then move it with Argo workflows. Very cool, again. And the last one, the last talk is from Kostis Kapelonis. He works at CodeFresh, one of the companies that has been founded by the Argo maintainers. this was about Argo rollouts. So you can actually do quite nice progressive delivery for stateful applications using Argo rollouts. With Argo rollouts and Kubernetes downward API, you can instruct your applications to read its environment variables from a file inside the pod, and then use hot reloading to actually point your deployment to its right mode. So, for example, you might have your canary and your live traffic. You can cycle through this very easily with Argo rollouts, since Argo rollouts integrates with your ingress provider, so the network traffic will be directed to the correct port. Again, very cool thing, but doing this requires a little bit of love from the developers too, so making them aware of these things is very beneficial. All right, well, I guess that was it for me. Probably don't have time for questions, but if you have questions about Argo, please.
We have time.
Oh, we have time? Okay, any questions about Argo? You can ask. I love Argo CD. And if you don't have a question now, I'll be around here, and I love GitOps and would love to talk more about it. So, thank you.
Next up is Erno.
I hope the Chromebook works this time.
They're all open source. You were showing in the beginning the 100.
And you can see it at least.
Yeah. Okay, so recapping a little bit about Kubecon, because of course the industry is all about AI, and so was Kubecon about AI. And with Kubernetes makes sense, of course, this is about large language models, but it also applies to all other generative AI. When we make a little bit of distinction, so who's been using some LLMs or is familiar with Gen AI, has been experimenting with Gen AI? Some people, yeah. But AI has been around for quite some time, and the difference between now that what we have been talking, until now we've been mostly talking about predictive AI, which focuses on it's like smaller models, very highly specialized models, and predicting and analyzing existing patterns on outcomes based on the classification, for example, clustering of some data. But for the past year and a half, all the rage has been around generative AI, and especially around the large language models, which are trained on a very large corpus of data. And with that corpus of data, you get these what are called the emergent behaviors, so that the models can give answers and answer even more kind of questions than and can function in a way that earlier on only the very specialized AI models could be helpful with. And with Gen AI, of course, there's other types of Gen AI, like image models. That if you've been using some image generators, you might be familiar with those. But usually, what we are talking about is these large language models. What ChatGPT is all about, and which has has become the industry standard. You're here from a Googler. Usually, I don't know also if you make a distinction between, you have the Gen AI and there's LLMs. Usually these interrelate, but basically what it means is that you have lots of data. And what's the difference between where the industry is going, that with the predictive AI is that, you know, there are much more players that actually have this data who can train these models. But with the generative AI, only the biggest players and those who can, you know, spend immense amounts of cash into, you know, training the models, because the training is not easy, and also that who have the data to spend there can create these what are known as the foundation models, who then all the other players can use and fine-tune. There are different ways to use and utilize generative AI models. And again, like different types of challenges that, you know, which exist for generative and predictive AI is, you know, with generative AI, if we look at the computational power, so extremely high, because it's just whopping amount of data that you need to use it. And if we especially look at, you know, how Kubernetes is being used, so think about, you know, Anthropics and AI24 and Mistrals, all of these like very, you know, prominent players in the Gen AI field who create their own models. They actually do most of their stuff running on Kubernetes. And it's, you know, it is not just hundreds of nodes, not thousands, but tens of thousands of nodes that you use these. It's tens of thousands of GPUs. And if you think about the price of those A100 or H100 NVIDIA GPUs, it is extremely expensive. So you need to have a really good business case in order to do this. Yes, massive diverse data sets for training, complex iterative training with specialized compute. So because when you, especially even when you are doing the inference, so you're actually doing the model, but especially when you're training the models, is that, you know, it might be that the model does not fit on one node. It does not fit on one GPU that you use to accelerate the model training, is that you need to split it across various nodes, various GPUs, and you get, you know, totally different types of problems trying to orchestrate this. And if you think about, you know, especially Kubernetes, there's some, you know, new developments on how to tackle this issue, because if you think that, you know, where Kubernetes kind of originated is running microservices. So, for example, all those images that you run on your in your pods, they used to be, the idea was that they are really small. But with generative AI models, the, you know, the images can be gigabytes. And if you think about, you know, then you get something like interesting issues like what is the startup time of my pods, especially if you need to do, you know, online inferences that you serve some Gen AI models to your customers and you want to keep it cost effective. Okay, like what are the kind of new mechanisms that I can use to make my, you know, nodes start up faster? Of course, storage and throughput, not just, you know, what you get out to the customers, but also how the systems talk to each other. Because how, for example, the accelerators, the GPUs, TPUs, FPGAs function best is that when they can talk directly to each other via network interfaces. But with the Kubernetes, the idea was that, you know, what kind of initiates the communication where all the communication pass is via the node. But, you know, unfortunately that gets highly inefficient. So there needs to be new ways of how to orchestrate these massive workloads. And yeah, that applies as well to the networking part. Again, there are, if you think about using Gen AI, most of the people here are familiar with using, you know, ChatGPT via the APIs. But then other ways also that you could host your own models on compute, either, you know, on premises, but quite often on cloud computing. So there's a lot of effort, and it was very, you know, featured prominently in Kubecon this year. Is, you know, what will be the frameworks for delivering the foundation for open large language models, and also for open Gen AI ecosystem. Because yes, the fact is that the ecosystem is dominated by those big companies. So how to, push for the open source ecosystem and have more say in that, so that the models would be free to use. And there are actually a lot of models, so I don't know who's were Hugging Face. Yes. So Hugging Face is kind of a, if you think about like a GitHub, it's a repo for AI models, and there's I don't know, at the moment thousands of AI models and large language models that are free to use, so that you can download them and run on your Kubernetes compute. But what it really is about is, if you one thing to use those APIs, but then why to run this on Kubernetes is, one thing is flexibility and control, that you have more control on what you are working with and how you want to use them, what you want to combine, how you build your applications, and also having the affinity. So, think about all the latencies that you get if your app runs in, some one region, and then you always need to call the API in a completely other region, and every time make the API call. This makes the flexibility and control that you can actually have your apps, your workloads, and then your models running in your same cluster. And what really comes to, because I work with cloud computing, I always forget that people actually run stuff at the edge or in their own data centers. It's really about also being able to run these workloads on premises and on the edge. Performance, really how to orchestrate and run these on a massive scale, and Kubernetes, how it was built, especially having the performance, the kind of reliability, high availability built into the system is one of the founding features behind that. And then, of course, what comes to efficiency and cost. So when you start with, it's very cheap to query those APIs, doing your queries and doing the prompting for the models. But the cost grows linearly. But if you run your own model, you can have a higher initial cost, but then it plateaus out, because you can have multiple models running, and especially if you run this on industrial scale, you can utilize your hardware better, and you can save money this way, that you kind of focus on having your own infrastructure, your own compute, and then utilize that efficiently. And that's also one of the, where the ecosystem industry is going, how to provide the best computing for this type of use cases. I don't exactly, I forgot to check it out when this was published, but it was recently published, that Cloud Native Artificial Intelligence white paper. It's interesting white paper, kind of outlining what is the use and what are the kind of principles that where the CNCF ecosystem wants to go related to the artificial intelligence. And it's not just, because mostly when we are talking about these, and if you look at the presentations and all YouTube material, it's about usually the inference, so when you are prompting those AI models. But then maybe the second one that you might bump to is training, but there's actually very little material on the training part, because that's highly proprietary stuff. Those who train those models would like to keep it, the information themselves and how to do it. But there's a lot of material on then how to use the inference part, so actually running those models. But it's not just that. The image is a little bit small, but there's more related to it. That, even with large language models, it's the whole MLOps lifecycle. So it's about the planning, it's the data preparation, and also in these phases, Kubernetes can help, because it's the kind of data science stacks, the CI/CD, the, let's say, general orchestration of your pipelines. Everything can be put into pods and run, as steps as part of your pipeline. Kubernetes is an extremely good platform for doing that. Then model engineering, model evaluation, that is basically what the training part is. Model deployment, that's when you run your models and get the inference. But also it's the kind of day two operation, so really the monitoring and maintenance of your language models. And there's like open LLMmetry is an open source project, again, to help with the monitoring of your large language models. I collected here a couple of talks because there's so much happening at the moment in the field, and what was done maybe 6 months ago, it might be yesterday's news nowadays. But there are a couple of, I think, interesting talks that I collected here, and also a little bit explaining what it is. So, number one, GenAI at the edge. Really, just to remind everyone, also including myself, that it's not just a cloud platform that the GenAI models run. This is a panel talk by a couple of people there, and it's interesting, perspective that yes, when you take your large language models onto the edge, and quite often they are, there's a lot of value for the intellectual property. So when you take them to the edge, someone actually might be able to get their hands on them, or might be able to steal them. So how do you actually secure these when you take them to the edge? Because most of them, actually how the LLMs run, and especially how the model servers are built, it's meant for the cloud, that usually no one else has access to them. But you take them to the edge, this can become a question. Then the number two is navigating the processing unit landscape. So it's about processing units. So Antti is going to talk about CPUs today a little bit, so I won't delve into that, but those are the most common processing units. But then there are GPUs, which the graphics cards, which do these like highly parallelized systems. So that's why they are so popular and so efficient with large language models and AI, because they can do a lot of operations in parallel. Then there's TPUs, so Google proprietary technology, so tensor processing units, which take the values and the calculations and do it kind of on a very large blanket at the same time. So that's what makes them again a little bit more effective. And then there's like the next talk is this weird contraption called FPGA, so field programmable gate array. That's right. So it's like I don't know, you would say like programmable processing units, so that it's highly proprietary code that you can use it. But even with these, because they've been very difficult to control in the past, but with AI, also these can be easier to program. So the AI can help on how to make these FPGAs, so they can be programming so that they are exact fit for your use case. That makes them like extremely performant. And also this talk, this third one here, is interesting also because it features all the kind of all the other steps that you usually have in your AI ecosystem and your kind of MLOps lifecycle, that how you can do and run those on Kubernetes, and what might be the challenges when you try to orchestrate everything, because with at the moment is that again, the ecosystem develops so quickly, is that you very quickly run out of support on your drivers. The models change, and they are being updated. So you need to constantly keep up on your ecosystem and how you fit your models so that they actually work your infrastructure. And if you have older models and newer models, and then because there's the high cost of the infrastructure, you don't want to have too much variance. So how you put all of this together. And that's where we get to the DRA, so demystifying dynamic resource allocation. This is a technology I think initiated maybe 2 years ago or something like that, but gaining huge popularity. How to better facilitate usage of any type of resource on your Kubernetes nodes. And again, the popularity comes from the better utilization of GPUs and GPU slicing. So if you take a look at the next talk, here is for DRA, for just-in-time GPU slicing. So again, GPUs are highly expensive. So quite often there's technology so that you can if you take one large GPU, how you can slice it or time share it between multiple nodes, so that several nodes can use one larger GPU, so you can have better utilization for it. For example, I talked to some of our product managers at Google a couple of weeks back, and the statistics show that only something like 70% of those like super expensive GPUs is used, and it's like these newer NVIDIA H100 GPU clusters can be 100,000. Just one cluster with 8 GPUs is $100,000 a month. So you would expect to have a high utilization for those. And another fact is that the GPUs always run out. So for the major cloud providers, they are always struggling, to get the GPUs for their customers, because there's just nowhere to get. They are in such a high demand that they are constantly stocking out. Then advanced resource management for running AI/ML with Q, so Q with K. It's one of Google projects, and it's about this kind of how to say it, add-on construct on top of Kubernetes scheduler to make scheduling, especially any type of batch workload, much more easier, so that it can control that, because for ML workloads and some workloads, you want to run all of the pods at the same time that contribute, one calculation, for example. So Q can be used to control these let's say, controlled manner of how you orchestrate your pods in your nodes, and also like how do you assign the quality assurance and what kind of time sharing you give between your pods. Confidential compute containers. Again, we get to the confidentiality part for the AI workloads, because you want to protect your IP. Then more of the familiar ones that everyone can go and try. So starting with some very high-level talks, recommended if you want to go and experiment how to run your LLMs. So it's actually really easy. Nowadays there are so-called model servers, like TGI from Hugging Face. Then there's the NVIDIA Triton and a couple of others, which make it really easy to run your own LLM models on your Kubernetes cluster. So basically, you just define in the manifest that which model I want to grab from Hugging Face, how I want to shard it, how many GPUs I want to run it on, and then just deploy the workload on your cluster, and it will make the magic happen. So it's relatively easy nowadays to start experimenting on your own. I've created a couple of internal tutorials. I'm happy to share them with you if you want to experiment, especially on Google Cloud, but just change the logos and it will work on AWS and Azure as well. Yes, please. Then again, like diving deeper into sustainability for the LLMs, I think it's kind of interesting that we've used so much time in a couple of last years to think about the sustainability for your workloads, but with the LLM craze, I feel that everything was just thrown out of the door, because no one really cares, because the fact is that the Gen AI workloads are the most resource intensive. So all those cat images that you generate consume actually a lot of computing resources. And the fact is that all the major players, they are so keen on having the market dominance that they are selling that compute capacity for very cheap, so that you won't even feel it, and it's even more easier for you to spend a lot of time generating cat images or poems or whatever you do. But bear in mind that it's very resource intensive workloads. Then getting to the application space is that, of course, the LMs don't live in isolation. So there's always, especially in the exploratory phase, you just want to explore that, how nice stories my LLM can create, but at some point it's really that you want to combine it with some application, and that's where it gets to the next one. So this talk talks about how to integrate and what are the technologies, and so that you can have them part of your deployment for the apps. And then again, like element deployments and strategies for efficient element deployments in any cluster, dives deeper a little bit that what types of LLMs I can deploy, and what could be the strategy for that. And the last slide quickly. So here's a couple of getting started resources. So this LLM started pack on the CNCF GitHub repo, which outlines very easy getting started piece on how to run your own LLMs. And then there's OpenLlama, which is a tool for running again large language models locally in Kubernetes, and it kind of again like an easy Kickstarter to get you started running your own models. Then, addition to the talks, there was a AI hub happening at the CNCF, which was kind of a open spaces style conference, so people could suggest their own topics and then start talking about what they wanted. So like a community and audience driven type of conference, if you're not familiar what open spaces is. What I found interesting is that and also this happened earlier when I had a meeting in Warsaw in the Google engineering hubs with 100 Nordics customers, is that because most of those people are actually practitioners, so they do not, so quite few, like even here, like there weren't that many hands going up. So even though that the industry talks a lot about Gen AI and large language models, and there was a lot of talk about this in Kubecon, is actually when it comes to practical things and application and how much people use this, is that the practitioners aren't that interested in. It's not something that is touching them on daily basis. They are like more interested in the more of the basic hurdles, running Kubernetes and doing GitOps and monitoring their workflows and scaling up. That's what people are interested in. They are not that interested in what it means to actually run these large language models in production, because it's very few companies that do this themselves. So even though that's a hot topic, everyone wants to talk about it, but I find it interesting that when it comes to who wants to participate and do these things, there are not that many. Yeah. Thank you.
Cool. And we'll have a 5-minute break
Yeah.
now, and then Antti can get ready. happy to have Antti here all the way from Tampere, right? This time and presenting his Kubecon talk. So that's really exciting.
Okay, thanks. Thanks. Can everyone hear me?
Yes.
Yep, good. Okay, almost there in the background. Sorry. So my name is Antti Kervinen, and this is joint work with Dixta Narang from Google, and we are going to talk about CPU affinity in this presentation. And what CPU affinity means is that basically we are interested in which set of CPUs you are using to run which set of containers. So this is, in a nutshell, all the thing. And one might first get the question that why on earth should I care? But I'll explain that. So I'll show why it makes sense to pay attention, and then also how you can actually control this kind of thing. So how to solve the problems that you would otherwise face with the CPU affinity. So let's go down to the business. Maybe one more thing about this title, by the way. We are saying here across your workload portfolio. So this is not only about AI. My first example is going to be AI, but this can be applied in all sorts of computations that you are doing in your Kubernetes cluster. So video encoding, databases, and whatnot. Okay. Thanks. So let's go to the example and answering question, why should I care about CPU affinity? So here we have a single worker node in Kubernetes cluster. And this is a rather big node, so it has 128 CPUs in it. It has like a quarter of a terabyte of memory, so 256 gigabytes of DDR5 memory. And then we went also, for this example, we went to the BIOS options of this machine and switched on so-called subNUMA node clustering, which sounds probably cryptic, but it means that here the firmware of this machine is actually exposing more details about the hardware topology of the processors and their internals. So this is two-socket system, and without subNUMA clustering, we would see only like two NUMA nodes in the system. So there's socket 1, socket 2, CPUs and memory connected to those. But when we use this subNUMA node clustering, then we can actually see 8 NUMA nodes, because there are 4 components inside each CPU package, and it actually makes sense to pay attention even in that level, that where you assign your containers. So which are the CPUs that your containers can use. That's enough about the hardware. What we are doing here is Dixita found some TensorFlow training benchmark. So we are running AI training on CPU, no GPUs at this demo. So we are running training on CPU, and we are plotting here throughput from that worker node. So we are interested in how many trainings we can run in a day or in an hour on that node. And we have 3 different setups. So first is these containers are allowed to use all the CPUs that they can find from this machine, so all 128 CPUs. Then we have 2 sort of competing custom setups where we allow each container to use 4 CPUs or just 2 CPUs. And when we run a single training container here, we cannot see too much difference on the throughput that we are getting. But when we add more containers, so we are scheduling more containers on that node. So here's the situation where we are running 8 containers. If we do not use CPU affinity, we get that much throughput, and if we have constrained these containers use only 2 or 4 CPUs, then we are clearly above in this throughput measure. And when we push more containers to the node, the difference becomes even more clear. So there is actually not too much throughput increase when we are not using any CPU affinity. So when we are using just bare defaults from the Kubernetes. But the increase is very significant when we are doing CPU affinity on those training containers. And when pushing to the limits, 20 containers was the maximum that I could get running 20 simultaneous AI trainings on the same node. And after that, we were actually running out of memory, so we were getting OOM kills. But this far we were able to go with this example. And again, there is some increase still in the performance if we are using CPU affinity. If not, then there's slight throughput performance still, throughput increase. So this is where you should care. You can get more performance. You can get also better isolation between workloads, which is very important in some other cases, but let's go those later on and first wonder that where this performance increase comes from, because it might sound a bit counterintuitive. So if you are not allowing to use these containers to use all CPUs, how on earth you can get better performance? Especially here when we are using like 8 simultaneous containers. The case is that we are not even utilizing all the CPUs that there are in this machine, but still the performance is much better. So the question is why? And here are some explanations. So first, there is thing called data locality. So when Linux kernel schedules your process in some container to some CPU, when we have fixed the set of CPU cores where this container can run, you can be sure that all the data that the container has is in the local memory. So it doesn't need to hop to the other socket and fetch memory from some other memory banks and then get the data back, which brings you delays. Another thing is cache hits. So if you have constrained workloads to use just a few CPU cores, you can be sure that those caches of those CPU cores and in larger scale caches of the whole socket, this is like L3 level caches, they are not spread, they aren't shared with so many workloads as they would be if there is no CPU affinity. So there are fewer users for each level of cache. And also, you can be sure that there are no far away cache invalidations, which is also an expensive thing. So you have 2 processes, two threads in different CPU sockets, for instance, accessing the same memory. If one writes there, the other needs to say that, okay, this cache is no more valid, and you will get more cache misses because of that. Third thing is CPU frequency. So this actually explains, on one hand, the thing that if you are using only few, like 1 or 2 CPU cores to do something and let the other CPU cores to be idle, what happens in the firmware in the system is that these idle CPUs can donate their portion of the power budget to those CPUs that are actually busy. So that enables a system to boost the clock frequency of those busy CPUs, and therefore you might get much more like per thread performance with higher CPU frequency. And then last but not least is that the workloads might actually behave much smarter as well. So now if you don't have CPU affinity, every training workload on that node sees all the CPUs and thinks that, oh, this whole system is just for me. And it might launch a thread for each CPU that it finds. And if you can imagine running like 10 of these kind of workloads simultaneously, then there are 10 threads for each CPU core in the system. So if you are partitioning this using CPU Affinity, then the workloads sort of understand that it's not all for you. Here's your part, and adjust their behavior accordingly. So this talk is named Beyond Default. We are working in the Kubernetes worker node scope, and we want to be able to use CPU Affinity for all the QoS classes of Kubernetes containers, so guaranteed, burstable, and best effort classes. What we are aiming at is better performance and better isolation. And the means that I'm using in this presentation is a very highly configurable resource policy for Kubernetes, which is setting CPU and memory affinity. And we are addressing these kind of problems that are like well-known problems: data locality, noisy neighbor, device locality. So it's not only about the CPUs. We can help also getting CPU cores close to a certain GPU that you might have in the system, or close to some smart NIC or FPGA. If you have such things in your servers, then you can run most critical stuff close to those. Then we can also address CPU attributes. So it is possible with these techniques to say that this container should be run on these CPU cores, and it should have a certain CPU frequency when it is running. So you can actually even configure that kind of things. And this highly configurable policy also enables application-specific tweaking. One case was, for instance, that we want to run virtual machines, and we want to allocate 4 CPUs for each virtual machine, but we want to share those 4 CPUs with 2 virtual machines in the system. So this is something definitely what you can't do with Kubernetes by default, but beyond default it's possible. So now bringing this into practice. So what's the difference between default and beyond default that I'm talking here? So this is the default system in a Kubernetes worker node. So when a Kubernetes scheduler has decided to run a pod on this node, what will happen? The node agent, kubelet, gets the information about the pod that here's the pod, here are the containers, run it. And kubelet starts to communicate with a container runtime. So we have CRY-O and containerd container runtimes, the most typical ones, graduated projects in CNCF. And those then pass the information to the low-level container runtime, like run C, which is then able to write actually to C groups in Linux. So there are CPU set.cpus and CPU set.mems controls in the C groups, which enable then finally saying to the kernel that these are the CPUs where you should run these processes. So this is the system process chain, and then Kubernetes managed containers. This default path doesn't include any of those, so there are just the workloads that we are running. And in this example, there is the pod spec of our benchmark workload from this AI training, saying that, yeah, I want to use 1 CPU for my purposes in this case. So how we go from this to the beyond default scenario is through NRI. So what is NRI? NRI is an interface that has been implemented to both CRY-O and containerd runtimes. And what this NRI now enables is that you can deploy Kubernetes managed workloads that then connect to this container runtime, and they get informed about every pod and container lifecycle event that happens on that node. And those NRI plugins can then make adjustments, whatever attributes are related to each event. And then those adjustments can change also these parameters that go to the low-level runtime, which means that they can actually affect what is written to the CPU set.cpus and cpu set.mems. So there we have a way to control CPU affinity. We can control also all sorts of other things in NRI as well. So there are lots of controls in C groups that are currently not managed and are not accessible by Kubernetes options, like swap limits, for instance, or block IO throttling and these kind of things. NRI plugins could change those as well. And as they are running in the same system, and if you would run these NRI plugins as a privileged containers, then they could manage the processes and get much more information as well. But now we are not interested in that. For CPU affinity, NRI plugin does not need to be privileged at all. So how we go beyond with NRI plugins? Here are a couple of commands to add Helm repo, NRI plugins, and then install balloons from that NRI plugin. So balloons is one of the NRI resource policies that we have available there in NRI plugins repo. And what happens then is that there's a NRI balloons daemon set that is created, which means that this kind of NRI balloons pod will be scheduled on every node on your cluster. And how to configure it? I mentioned the highly configurability. You can just edit the CRD of that balloon. It's great that we are going to have a CRD talk after that, so we will get more information about CRDs then. But now it's enough to say that, okay, there's a way to configure this policy with a CRD. And here is an example CRD that defines balloon types, and this defines only one balloon type, which is an AI balloon. And in the example, I mentioned that we have CPU sets of size of 4 CPUs and 2 CPUs. So this is an example of this 4 CPU sized CPU set. So every time there's a workload coming, this balloons policy will decide what balloon should run that workload, and here we can define that. Well, we have defined only like one balloon type with 4 CPUs in it. I don't now go to the details of the other options, at least not yet. Well, I lied. Maybe one option. So there is a namespaces option in this balloon type, which has now star here, which means that if you have scheduled pod that runs on any namespace, put it to this balloon type. So you could do like namespace-based separation of which container or which pod goes to the which balloon. But there's also another way you can annotate your workloads. Like here, we have annotated this AI training workload to say that which balloon type should be used to run this workload. Okay, so here's what is happening. We have deployed the daemon set. NRI balloons container is now running on this node, and it says to the NRI server inside container runtime that, hey, I'm here and I'm interested about this kind of container lifecycle events like creating container and removing container. The NRI server welcomes this plugin and says that these are the containers that are running right now. So this enables the plugin to actually start managing already running containers on that node. And then a couple of scenarios of different balloons. So in this AI example, in the first slide, I had these 4 CPU balloons. So what happens and what has happened there looks something like this. So when the kubelet says that now let's start an AI container, then the container runtime says to the NRI plugin that hey, we are starting now a X container, and this plugin answers that put it on these CPUs. So there's a balloon created in the system which consists of these CPUs, and the new container is associated to that balloon, which means that the CPU set.cpus will be filled with these values. That was a fixed size balloon. You can also have like balloons with size of the requests of containers. So in this case, X is asking for 1.5 CPUs, but we can't create a balloon of 1.5 CPUs, so we create a balloon of 2 CPUs because there it fits. Balloons don't necessarily be statically sized. There can be also inflating and deflating. So in this example, a new container Y is being created, which makes these NRI balloons to fill and inflate this balloon by adding it one more CPU into it and saying that now both X and Y should run on these 3 CPUs. So it can actually modify the CPU set of a running container in this case. And we can then also isolate workloads, give like fully exclusive sets of CPUs, and always aligned with the hardware topology so that you will get the data locality and stuff. And there's also a way to say that there are some exclusive CPUs, but there are also some shared CPUs to workloads on these balloons. So if there are CPUs that are idle, that is, they are not allocated to any balloon explicitly and exclusively, then those CPUs can be shared within chosen topology level in that machine. So same socket, same NUMA node, these kind of options are available there. So what's the difference now? Well, default versus beyond default. Kubelet, the node agent, has CPU and memory and topology managers, and balloons is actually replacing all of those. And if you are using these managers in kubelet, then you are limited to managing CPU's affinity of guaranteed containers only. But balloons is handling all these QoS classes. With default managers, you can decide to give exclusive CPUs to guaranteed containers per a container or per a pod. And this is a node level configuration option there. But with balloons, you can have like exclusive and shared CPUs, and you can choose freely the group of containers. So for instance, if you are running several database containers on the same node, you can run these, several database pods, and each pod would contain a database container and a logger container or some other watchdog. You can take all these database containers, run them on exclusive CPUs, and all logging or watchdog containers from those pods you could put to the same CPU in the system. So there's a lot of possibilities to mix and match. So managers provide only static CPU sets, and as I showed with balloons, like inflating, deflating scenarios, there can be also dynamic CPU sets. And managers have like limitation on number of NUMA nodes that can be supported because there's actually algorithmic problems, I would say. So there's an exponential algorithm which totally kills your machine if you have more NUMA nodes than 8. Even 8 is actually a pretty tough one for it. And you will always manage containers on the NUMA node level, but in balloons you will have many like topology levels that you can use, and there are no such limits. Like you can even go to the hyperthread cores where you, if you like, and you can also get NUMA nodes and dies. There can be several dies inside the same CPU package, and then also package level naturally. And also beyond default there is like CPU frequency controls, cache sharing on what level you wish, and then also live tuning. And I wish to end this presentation with live tuning. No demo, don't be afraid, this is actually running on airplane mode, so nothing bad should happen. Here I have a balance configuration that I'm using in this live tuning, and the things that I'm chasing here in my compress balloon type, I have a workload that is doing some stupid compression. But anyway, I think that this is a good demo for the performance case, and also this live tuning case is so that I have the container doing some compression and random number generation on the node, running all the time, and what I'm changing is only this configuration, this CRD in the Kubernetes, and I'm editing the maximum number of CPUs, minimum number of CPUs, and also an option that how to select those CPUs to this balloon that will run this compress example. So this flag is, in this case, it is spread on physical cores. So if false, then I'm selecting those CPUs possibly so that they are two hyperthreads of the same CPU core. But if I'm spreading to physical cores, it means that I'm always selecting those CPUs so that they are never hyperthreads. So they are always from different CPU cores. And here is what I got. So baseline, when I'm running this container and I'm measuring again throughput, how many megabytes per second we are getting through this compression, without any CPU affinity. Here's the bandwidth, and then if I run this and change the configuration so that, yeah, let's start the balance NRI plugin and let's use only a single CPU, no more, then the bandwidth is actually dropping because having several CPUs would help, but what we get is actually a flat line, which is sometimes very nice, so you can get very much predictable outcome from this. So adding one CPU, running out total 2 CPUs, we are already getting more bandwidth than in the case where we were able to run on any CPU of this 128 CPU system. Again, adding third CPU, some more bandwidth gained, but now we are seeing some fluctuation. So this is not flatline anymore. The bandwidth is changing. I first thought that this might be due to the clock frequency going up and down when the kernel is scheduling this on these processes on different CPUs. So I first changed minimum frequency. I maxed it out, but it seems that it didn't have any effect on the throughput, so probably the clock frequency was already maxed out. So there I tried another option, so here I went to the spread on physical core. So don't allocate CPUs from the same core, these hyperthreads from the same core, always use different, and that actually was enabled removing some of that fluctuation. So this is, the point here is that you can play with this thing and change the configuration on the fly without restarting and without training your node that you would have to do in the default case actually. Okay, good to conclude. What I've been talking about, what are the sort of dependencies here? This NRI server is now enabled in container T 1.7. Well, it is there, but it is not enabled by default, so you will actually have to switch it on in the container D configuration. Or if I go few slides back, I think that we have actually here when you run helm install, there's an option that patch runtime config true, which means that our init container tries to be smart enough to go to the container runtime config and switch the configuration on. If you start thinking about, wow, what's happening here? You are running a container and you are actually changing the container runtime configuration, then if you get scared, don't think it more and just wait for containerd to release 2.0, because there it is enabled by default. And also Cryo 1.26 already included NRI server, and the same story there. So it's by default it is disabled, but pull request is in to enable it by default. And a word about these resource policies in NRI plugins that are already available. This presentation was about the balloons policy, where you can configure a lot, and unfortunately you actually need to configure a lot. But if you don't want to configure a lot, if you just wish to get things working and get the benefits of CPU affinity to the extent that it's automatically possible, then there is this topology aware policy, which is like a zero configuration policy. You don't need to care too much, just run your pods and run your containers with this thing deployed in your cluster, and you will get pretty good performance actually already out from there. And then there's also a template, a resource policy, which is a good starting point for writing your own policy if you like. There's try at home live tuning. No comments about that. Okay, some links to these projects, and also there's a nice blog post by Ferus on this resource management and resource policies in NRI. Thanks for your attention.
Couple of questions where the last one probably was already answered. But the first one, you had a Kubernetes declaration that had a specified CPU1. The ballooning configuration, does that override the CPU1?
No. So this is resource requests, which affects that on which node this is scheduled, and this request is something that the balance policy actually reads. So it finds out that, okay, this workload, this container needs one CPU, so I can't put it into a balloon which doesn't have at least one free CPU in it. But it doesn't change this. However, if you would be running here in the kubelet, if you would be running this CPU manager, memory manager, topology manager, then what kind of CPU affinity those managers would include to the CRI Linux container resources information, that would be overwritten by balance policy and by other policies as well. So when running NRI resource policies, it's a good idea to keep these default resource policies, default managers in kubelet disabled completely. So running them would be just a waste of time.
Okay. So the next question was basically, since there are different hardware configurations, what would have been optimal setup for the ballooning and stuff, but there was already this that automatically can configure it to that, so it was actually answered in the later slides.
Yeah, that is true.
But I presume that you can still get the configuration from there and then hard code it later on.
You can always, when you have your workloads running with your resource policies, you can always go down to the C group level and the process CPUs allowed, memory allowed level from the proc file system to figure out that what are actually the CPUs where your workloads is running at that point. So whatever the policy is, you can sort of figure out from the system that where it is, which CPUs are allowed to which processes. So I don't know if I answer your question, but that, yes, that would enable hard coding.
Yeah, I guess it helps forward, yes.
Yeah.
Thank you.
I would have another question. From where the scheduler knows that the balloon policy can be fulfilled on a particular node?
Excellent question. As well, this balance policy itself does not expose directly to Kubernetes any information that these balloons are available. This is something that currently needs like node labeling separately, saying that here we have balloons policy running, and maybe mentioning the balloons types which would be there available on the node. So no system yet, but I think that this would really make sense to include it in the whole setup, so user wouldn't need to configure this kind of thing.
Anybody else?
Okay, thanks.
Thanks. And 10 minutes again. Feel free to grab some more drinks or talk to each other, and then Janne can get ready.
Älä lupaa mulle antaa juotavaa.
Okay. Hello everyone, and welcome to listen presentation with CRD usage with the IDP. My name is Janne Välimaa, and I am a cloud architect at Elisa. I'm leading project of IDP, IAM platform, API platform, and I also use multiple clouds. So in here, the story is quite easy to follow. First of all, if you use multiple different clouds, then you automatically drop into Kubernetes world. And here, as I am leading IAM and API platforms, we have to start getting the other developers to use these platforms. And the easiest and very obvious way to do this is by IDP, Internal Developer Platform. So the background of this case is that we have multiple subsidiaries. Lately, Elisa has been very keen to buy smaller companies to help our industry development. And these subsidiaries have different ways of work. Some of those subsidiaries like to work in the cloud, and some of them do not. Some subsidiaries actually believe that their clients doesn't want to go to cloud, and we have to take them part as well. So, unifying tools and methods. I started research book to identify could we use CRD for IDP, and what is the pros and cons. And this research was because I love programming, and I love to take one step further. So when we had IDP, I wanted it to be more easily to taken in use and more developer friendly. And that's why I wanted to start this this project. And let's start from internal developer platform, what it is and what it does. So most simplest one is actually having template and common usage for that. And this is the way of sharing code between developers, that your all developers will start with the same point and will use the same tools. This is not platform yet, but as a platform can be almost anything. So platform is not so defined that you always show that, okay, here is platform and this is not platform. Common tools and usage are usually the key what you want to give here. We wanted to speed up development, and we also wanted to push developers to use IAM and API platforms. And the reason for this was very obvious because many developers were ML engineers, and you can believe that when they made APIs, they were not secure at all. So we wanted a little bit security there. And also we could a little bit follow their usage, that how they want to develop and do their own proof of concepts. Because one of the big problems in the companies like this have that you have multiple developers. They want to do some proof of concept. They want to try out something. How you follow up? How much does it cost for you? So you have to little bit make some agreements in here that if you do this kind of testing, could it be costing like this? And saying the same things to multiple developers ain't gonna work. You need something that unifies your tools, and in these tools you can actually embed all kind of tags and follow-ups that you can actually follow how different people use their projects. Okay, and let's start for IDP installation. This is very simple one, very simplicity. We in our IDP, we have API, command line interface, we use envoy operator, where we go much more later on, and user interface. And the IDP Kubernetes, which we install, can be installed both in the cloud or on-premises or anywhere where you have Kubernetes. And in case when the installation happens on-premises, it's not actually so much IDP anymore. It's actually just installation tool for us. It's the way how we can manage your Kubernetes environment. So we just, for simplicity, use the same name for it, even though the use case do vary a little. Okay, and IDP architecture, how IDP is meant to be used. In our case, I didn't want to go on backstage. Well, everybody's saying it's very good and it's central. I believe that, but right now I didn't have enough developers for this project to someone to start learning how to do that. But we had already existing skills to develop extensions to Azure DevOps. So we went with this. So we have this UI in the DevOps, which then gives user good UI to do things. But all the logic is happening in the operator and the API. So to take usage of the backstage later on in our steps would be possible. So we can just define that one point of time we want to actually change the front end, which most likely going to happen at some point, because having DevOps extension developers is not so easy. So if you want to go markets and ask, hey, how many of you know how to develop this? They don't, but it's made by React. So you just basically say, whoever knows how to create React programs, you can come and do those. Okay, and then a little bit more specific view of IDP architecture, how the teams are meant to use our IDP. So every information you want to give to system should go via variable group. So you have variable groups and you just add information in there, and then our automation automatically picks that up and pushes it into the system. In Azure DevOps, there is actually in variable groups secrets and normal information, and that steers that will this information be secret or just a variable in config map. And the team will just create feature branches, then pull request, they go to main, and from there they CI will take care of first step, and ArgoCD will then take care of others. So we have this management cluster and app cluster. In here we have eyes as a resource group, but in the end way it can be any other Kubernetes anywhere. And for now, the team doesn't take care of how the customer will enter the system, because it's taken care of the IDP. Okay, and let's take a view from the developers. So how developers should, from our perspective, how I see that I want developers to view the process with the infrastructure. The main concept in this tooling is to have this root custom resource. And custom resource always gives you AIM and AP platform. So when you run this to any Kubernetes, the Kubernetes now will have our system running in it. Also, when you want to point this system into some DevOps that, hey, my source code is over there or wherever, you can then use Azure DevOps Connect. And here you just give some information what you want it to know, and it will connect. And now you can easily connect your system to Kubernetes. And the one level we have here is customer. This is most likely not used in a SaaS case, but as I earlier thought that there is multiple different use cases. And even though we want to push all our application to work as SaaS, we have some customized code and customized APIs. And you can put those APIs behind this customer. And in here, you can give parent as root. Then you're going to have this AIM or API platform. But theoretically, you can even leave this out, in which case you don't have those. You have to develop those by yourself. It's meant to be like that. It's bad decisions because then somebody might actually do that. So developers just then need to know that, okay, then it's not so safe to use. Then you have project, and in project you usually just say this is just abstraction. This doesn't actually do a lot of things. This is just mental abstraction, how you structure your project. So we use this for FinOps. We use this to look scaling, that if we know that we have some kind of application or application groups, projects, should they have what kind of possibilities to use different kind of nodes or resources, etc. So this is mostly abstraction out of that. Project can have product. So in this case, if product is inside the project, you cannot install the project without product. Now you have some product inside it, and it's just basically this look very similar because it uses a lot of the same code. But you also can have product which is entirely outside of the project scope. And now you just can take this one product and push in the multiple projects. So in this kind of deviation, the developer or whoever wants to release this has easy way of understanding how we manage and how we abstract these things. Only thing that you have to know that in here, that project is actually just for our use, and it's abstraction for the marketing or management people. And the developers usually want to just release products, and they are just interested of this. So there is multiple different ways of thinking this. Yeah, so this is how we want to develop systems for the developers. It should be easy, small, and very efficient. Okay, let's go to the Kubernetes side then. So what happens in the Kubernetes? First of all, to understand how the CR works, or CRD, we have to understand controller. So controller controls loops of Kubernetes. So every time you create any resource in the Kubernetes, it's going to this reconciler loop, which is going to reconcile system that do you have this namespace, for example. And if you don't, you will create it. And this is the controller part of this development. Then the other thing you should be aware of when you start to develop custom resources is API resources. And API resources are those what we use all the time: config map, events, nodes, etc., pods. And this is the thing that we will going to extend in the our system. But API resources are just endpoints you can call in Kubernetes. Okay, Custom Resource Definition, CRD. Operator is way to pack, deploy, run, manage, and maintain Kubernetes applications. And operator basically extends controller. So you can kind of think that if you have CR, you have custom controller. They're basically the same thing. And therefore, the custom resource is just an Kubernetes API extension, which we looked earlier, that there was all those pods and config maps. And this API extension now is what you can call. CRD is just a schema which explains what data you send to this. CRD is just schema for CR. So they are kind of easy to understand. You just, when you get your head around it, they're very simple, and they are just sometimes too simple that you just forgot that, hey, this is nothing very special. It's just, CR is just an API extension, and CRD is schema for CR. Okay, let's take operator view. This is a little bit bigger view. Okay, so I created this code by operator SDK, I think. And let's start from the CMD as it's the main of Go. So every time you want to create yourself operator, you need this main where you're going to explain that which reconcilers you're going to use. So root reconciler is the reconciler for the root CRD, which we saw earlier, that when user will send a root call, then this root reconciler will actually go through and make all those things, what happens behind the scenes. And product reconciler, they're all similar. Nothing, here is actually nothing interesting, as if you use operator SDK or some others, they usually automate this file. It took me a week to notice even this file, because you don't usually just come ever in here and do anything with this. So to understand that, hey, I just have main file here which does something or something, well, now I understand a lot of more. And why I had to come into here was that in here you can actually add different schemas to your application. So we used at one point this hierarchical namespace application because we wanted hierarchy in our namespaces, and the way of doing it was actually have it attached in here. So now my application could use it, but nowadays we just have we are using the dash, which then says project dash product, and that's the namespace of it. Let's then look at an API. Here is data, what we can now take and use in our system. So, not status, but spec. Root was quite easy. We only take name, so you only say this is my root name, whatever you're going to have. But it actually had a lot of statuses what I can have. So status is something that I can save information, is something done or not. We go a little bit more details on that later, but for now we just need to know that CRD also defines that what information this seer actually can now save and in behind to go forward. Okay, and here is, let's take Azure DevOps content types, for example. This has more information like organization, projects, which is just yet another struct in here where is more information about it. But these files are now generated automatically, so we just say to the make manifest, and we're going to have these kind of YAML files. So you could actually write these YAML files by your hand, but as many being developer loving to do some code, we always want to do things with code and never write YAML. So customer resource definition, it's the kind, and in here I just explain that version 1, and let's go to the more important part here. So here is properties, what kind of information I will take into my system, and it's very difficult to read from this perspective, as it has object over here which then going to be over here, and it's much easier to understand from the Go side what it does. But it's also explains here the status. So this is the status and what it can save, and the properties in here we can say spec here what kind of information you can send it to the. Okay, so this is quite clear, I would say. Okay, and hack is a folder that took also 1 week for me to understand why this exists, and I eventually find it out that if you want to do some your own developer bash scripts or something like that, you can put it in this folder. They just have named this folder very funny way, so nothing special happens in here, and we don't use this at all because our development uses Azure DevOps, which does all those scripting, etc. So in the internal, we actually have the code itself, controllers. Let's open Azure DevOps Connect and let's look what happens here. So maybe I also show here how we get here, because this is quite actually simple. If I just follow in here, let's take Azure DevOps controller, and now we got into the same file. So we can see that the main just points out this function and, or actually method, but anyways, and this then explains how I will start to do reconciler. In here, we don't actually need to care about this information. It's not very interesting, but this reconcile function is what we are interested in. About this, you don't need to worry about this. Kubebuilder is just using it because it automates a lot of stuff for you if you want to do different stuff, and that's why they are there. Okay, so first I will check first I do the frap request. This is custom method here, where I just take information out of the call. So information, you just send it to our Kubernetes system. We just check it, what you're going to have in there, and I just wrap it up so it's easy to call in the later stage. Let's go back up. So that's why we have information nicely in the manifest. And the first thing I check is this deletion. So if you're going to delete your custom resource, you're going to have there as timestamp. And if you're going to do that, then I will delete my own information, what I have set here. So whatever your custom resource has created, you can now remove it in here. Here I remove finalizer. I should probably check the info have they been done correctly, but in here we just then remove the finalizer. Finalizer is a way of saying to Kubernetes of your custom resource that should Kubernetes remove this now, or should I do something with it before? So just with the finalizers, I say don't remove it yet, I want to do something with it, but now when I'm done, now I remove finalizers and I say Kubernetes, you are ready to destroy it. So we're just going to update the status of this resource or information, and then the Kubernetes is going to be happy. And we're also going to return empty result and no error. And if then the call is not deletion, then we're going to check that does the status have secret. Now here is a couple little bad things, that now the system doesn't actually check does the secret exist. Theoretically, here you should always check it from the system, because now if the user removes the secret, then the system believes that it exists because it's only checking it from the status and not from the actual location. But then it depends how important system is that should it be checking that. Here we create the secret, so I just show it. Here, okay. So in here I just say core. This is important from here, so we use just Kubernetes core version 1, and I say that I want this secret resource. So like I said, If you want to use others than Chorus, you have to import them in the main. And I just say name and what namespace I wanted, token, and etc. of those, and then I just create that. So now our system is going to have a secret. And of course, if we want to delete it later, it's going to be done in there. So this is state matching, what you always recognize this system to be. But it's good. I like state systems. And in here, maybe this is mentionable that I return an error. So I say that something didn't work out. I check it. If the error was something else than already exists, so if the secret exists, I'm fine with that. I don't want to do anything. But if the error is not that it exists, I want to wait 10 seconds and then return the error. So if you're going to look any of the examples how they do, they usually don't put this, but it's going to be very funny to read when you debug your system and you just run and there's going to be error. The system is going to loop and it's going to run those error messages all the time very fastly. So this 10 seconds is just for me to understand, hey, there's error, just Control C, don't do anything for now. So I recommend personally to do this. Same thing with config map, we will check, nothing special happening there, same things. Create config map, if already exists, just ignore, and otherwise wait 10 seconds and do something. Of course, I don't have good error checking here. If it didn't work at the first time, why I'm thinking it's going to work second time? Well, I'm just positive in that way, but in the future there are going to be piece of code that will actually check that what kind of error we have. Can we do something with it? If we cannot, then we just going to not going to endless loop of errors. And when I'm done with all those updates I want to do, for example namespace and config maps, I add finalizers over here. So finalizers are again those information to Kubernetes to know that should it destroy the resource or not. So I just say, hey, don't destroy this system before I have removed these finalizers. Okay, and then other interesting information there isn't. So basically this CR operator is very simple, very easy to get used to it after you get your head around it. There is few fallbacks where you really need to think it before you really make it happen well, but I would say it's quite easy to manage and easy to do. And yeah, I will probably personally start to use operators much more. Okay, so that's about the operator view. Let's summarize them. So the pro things is that you have total control of it. So for example, in our case, we create service accounts. Because we have multiple different units and they can do a lot of things, I don't want them to be able to deploy on top of each other. So every time you want to start a project or product, you're going to have service account which is going to have rights to this specific namespace. So you kind of have this namespace and you can do whatever you want in there, but you cannot go anyone else. And it's automated, so no one will know the secrets, and that's why it's more secure. Also, it takes care of some Azure DevOps grouping, etc. So basically what it does is that every time you create a product, it will create you specific groups in there, and automatically check if it has to add people in there. There was more logic in there, but afterwards, it's very difficult to say what should be in the API, what should be in the DevOps, and what should be in the operator. So theoretically, you can put everything in the operator because scalability is endless. It's code. You can play Pac-Man in it if you want. Cons, it's expensive to create and maintain. So basic coding is cheap. Running it is cheap. But if you again want to know that if you have 10 developers and you will ask them how many of you have done some helming and how many of you know how to do things in DevOps, everybody raises their hand. Everybody knows how to do these things. And when you ask them to use operators, maybe one hand raises up. So you have to put less people to do something that you could have bigger pool of developers to do, which will now create in the situation that developer time is expensive in here. Maybe I should said that developer time is expensive in here, but it's expensive to create and maintain. Azure DevOps limited access management is a little bit problematic in here in our case. GitHub partly yes, but in this kind of situation you usually now have to ask that what kind of things you can put behind the Kubernetes. So